I wanted to make a short follow-up to my quadratic formula video because in the last one where I introduced the quadratic formula, I carefully constructed all the examples to have nice, neat whole number solutions. In other words, all of the roots were either whole numbers or you didn't have any roots or you had one root, something like that. But remember, I promised that the quadratic formula could be used for any type of quadratic, whether the roots are whole numbers or decimals or whatever, right? And to be totally transparent, uh, if you get whole number solutions, that means you could have factored it, right? Whether you did or not, or whether you know how to factor it or not, in that particular case, is irrelevant. If you get whole number solutions when you perform the quadratic formula, that means that the original function could be factored. So every example we did in the last one could have been factored if we wanted to do it that way. All right. But what happens if you have functions that are not factorable and they don't turn out so nice and pretty? So I want to just give you some examples of that and show you how you might plot those things on a graph. All right, let's just jump in. Let's do something like this. Okay, immediately we should recognize this is not factorable. There's no way you can multiply anything times anything else to get 3 and simultaneously add to get 5. That's not going to happen. So you can't factor this. So that means we're going to get something more interesting than we got last time. So let's use the quadratic formula to find our roots. Let's remind ourselves what the formula is. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I highly encourage you to memorize this formula. It's going to be very useful to have it memorized so you don't have to keep going back and forth and writing it down and things like that. All right, negative b, that's negative 5 plus or minus the square root of b squared. B is 5, so b squared is 25, minus 4 times a, which is 1, times c, which is 3, all over 2 times 1, which is just 2. All right. Now I'm going through these pretty quickly because I'm assuming you've done a whole lot of examples of these calculations from the last video. All right, 25 minus 12, right, all over 2. That's going to give me negative 5 plus or minus the square root of 13 all over 2. And this is where it starts getting a little different because in the last video, everything here under the square root, we could either square root it or it was 0 or it was negative, something like that. But here, you can square root this. It's just going to be a gross, decimal. Now, a lot of applications or a lot of times you see this kind of thing, they want you to leave it in this form. They'll say, okay, just do the quadratic formula and leave it in radical form. If they say leave it in radical form, they just want you to leave it there. So if you can't actually perform the square root, you just leave it like that. But if we want to actually plot this on a graph, we have to have some kind of estimate. We have to estimate what this is going to be. So let's do that. Let me change colors and go up here. And this is no longer equals. We're going to say this is approximately. Because as soon as I take the square root of that and start rounding things, it's not going to be exact anymore. So I'm going to write negative 5 plus or minus. Now I'm going to punch in my calculator what the square root of 13 is. And depending on how you do all this and where you round, your answers might be slightly different than mine, but I'm just going to pick 2 decimal places. So this is 3.61 rounded up, divided by 2. All right, that's going to turn into 2 different problems as it did before. That's negative 5 plus 3.61 over 2, and negative 5 minus 3.61 over 2. Oh, let me write that a little better. All right, so we do that calculation. We have, let's see, 3.61 minus 5 divided by 2. That gives me negative 0.695. I'm going to write 0.70. I'm going to round up. So we have 2 decimal places. And then I have, this is negative 5 minus 3.61, which is 8.61 divided by 2, which is going to give me, what is that going to give me? Negative 4.31. All right, now what's interesting is usually when you look at these, they're going to complement each other. So 70 and 30, or 69 and 30 and 31, depending on how you round it, it might be off by one. But if we had done this exactly, so the exact solution, actually, let me show you. This would have been 695. So maybe I should do it this way. And then this is 305, right? And if you add these numbers together, it's kind of fascinating to me. If you add them together, you get 1. So they're going to complement each other to add together to get a whole number, if they're both negative or if they're both positive. That's just a kind of a side note. It's not really important. It's just kind of interesting to note. Okay. All right, let's do another one. Let's do y equals negative 2x squared plus 3x plus, let's actually change that to 6x plus 1. All right. Actually, let's change this. The reason I'm changing it so much is because I'm trying to ensure that we get something that actually gives us roots. Let's go with 8. All right, let's give this one a shot. So I have negative b, which is negative 6, plus or minus the square root of b squared is 36, minus 4 times a, which is negative 2, times c, which is 8, all over 2 times a, which is negative 2. Now, if I'm going through this too quickly, don't be afraid of pausing the video and working through this yourself. Do that first. I'm just going through these calculations quickly, just because as we get used to doing these, and you get easier or you get better at it, we're not going to waste time with that. But again, feel free to pause the video and work through it slower if you need to. Okay, so I have negative 6 plus or minus the square root of 36. This is plus 64, all over, you know what I just did? I just made something that's factorable. Well, we're going to keep going anyway. Why not? Okay, so negative 6 plus or minus the square root of 100 all over negative 4. That's negative 6 plus or minus 10 all over 4. That gives me what? What does that give me? That gives me 4 over 4. And it gives me negative 16 over 4. So that's 1 and negative 4. Well, I tried to make a random problem that didn't factor evenly. Turns out you could. So, my bad. Well, we got more practice doing it that way. Let's try another one. I know this isn't going to be factorable. Okay, let's try that. Okay, pause it, give it a shot, come back, we'll work through it together. All right, so I have negative b, it's negative 7, plus or minus the square root of b squared is 49, minus 4 times 1 times c, which is 2, all over 2 times 1, which is that. Negative 7 plus or minus the square root of 49 minus 8, all over 2. Negative 7 plus or minus the square root of 41, all over 2. There we go. Now we're getting a gross number. Okay, so now we're going to have this square root of 41 stuff going on. Change colors. Negative 4 plus or minus, what is the square root of 41? Let's type that in. 41 square root. All right. This is going to be 6.40. Let's go with 6.40 divided by 2. All right, so that gives me, all right, so negative 7 plus 6.40, that's the same thing as 6.4 minus 7 divided by 2 is negative 0.3. And the other way around is going to be negative 13.4, right, divided by 2, which is going to give me 6.7, also negative. Okay. And notice how I said before, it's kind of cool if this pattern shows up. if both of these are on the same side, this kind of makes sense. If both of these are on the same side of the y-axis, then these numbers here are going to complement each other because it's symmetrical around some point. So if that makes sense to you, then it's just another added layer of symmetry and beauty to what's happening. So 0.3 and 0.7 added together to give you 1 because they're symmetrical, right? All right. Great. Let's try another one. Let's see if I can make one that shows something else. Let's do x squared plus 4x minus, let's say, 8. Okay. All right, let's see what happens with this one. All right, pause the video, try it, come back. I'll do it. Okay, here we go. Negative 4 plus or minus the square root of 4 squared is 16 minus 4 times a times c, all over 2 times 1, which is 2. Right? All right, so now I have negative 4 plus or minus the square root of, this is 16 plus 32, all over 2. Negative 4 plus or minus the square root of, what is 16 plus 32? That is going to be 48, all over 2. Almost a perfect square, so close. But we don't want one right now, do we? Because we're trying to get gross numbers for some weird reason. All right, so negative 4 plus or minus the square root of, well, let's actually calculate this. It's going to be just under 7, right? If you think about it, the square root of 49 is 7, so this should be 6 point something, close to 7. Let's see. 48 square root. Hey, there it is. All right, so we get, let's go with 6.93. Right? And that's going to be divided by 2. All right, so now let's work out both solutions. Now I have negative 4 plus that. So in other words, I have 6.93 minus 4 divided by 2. It's going to give me 1.465. We'll round it to 7. And then the other one is going to be, that's negative 10.93 divided by 2, which is going to give me 5.47, right? But negative. Now, here's another pattern that kind of emerges. That's kind of neat. Like I said before, this is not necessarily imperative that you use this, but I think it's fascinating. Notice that these now lie on different sides of the x-axis, right? Oh, that's not right. So I have 1.47 here and then negative 5.47 here. And if they lie on different sides of the axes, then these numbers here will not complement each other. They will be exactly the same, right? And if you think about how things are symmetrical and how they work on either side of the axis and how the number line moves out from the origin, you can convince yourself that this pattern, this beautiful symmetry, makes sense. Okay, let's actually graph this. Let's actually try this one out. So let's see, it's 1.47 and negative 5.47. Let's go to our graph thing over here. So let me get something that shows up a little better. 1.47 and negative 5.47. So let's zoom in here because I want you to see this isn't really that bad. 1.47, negative 5.47. Where do those go? Well, 1.47 is basically just 1.5. So if I were to graph it, would be where? About right here, basically in the center. And then negative 5.47, 1, 2, 3, 4, 5.5, almost exactly 5.5, basically. And that's where that would go, right? Maybe a smidge towards the middle. but that's how that works. Okay, so even if you get these weird decimals, you can still graph them. That's where those roots are, and they are accurate. Now, let's go ahead and find our vertex just for good measure. What was our function? Our function was x squared. Before I waste time, let me go make sure. X squared plus 4x minus 8. I have to reference it. I don't have notes. Again, I just make these up off the top of my head. So gotta go make sure I got this right. There's that. All right, let's use our vertex formula. Negative b over 2a, 2 times 1, right? Which is just negative 2. So that's going to give me my center line, right? So that's where the vertex is going to lie, which makes sense if you think about it. So this is 3 and a little bit, and this is 3 and a little bit, right, from there. So it's symmetrical. It's exactly in the middle. And to find how far it goes up and down, we just plug that back in. Negative 2 squared plus 4 times negative 2 minus 8. That's going to give me 4 minus 8, which is going to give me negative 12. So if I wanted to plot this, I would go all the way down to the negative 12. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there it is. Okay. All right. So point is, even if you get these gross numbers, these decimals, you can still graph them. They still are valid. They just, don't look quite as pretty as they do when they line up on whole numbers. Okay. All right, I think that's going to do it for this video. And in the next one, we're going to move on to the vertex form of the quadratic. It's going to be a different form, and then we're going to compare and contrast that with the form that we've been working with the last couple videos.